Welcome to this presentation on option gamma, an important option in Greek. I am Aninda Datta, the presenter. As gamma indicates the sensitivity of delta to change in the underlying asset spot price, so gamma assumes high importance in risk management. We'll cover the following areas. What is option gamma? How to calculate the value of option gamma? Relationship of gamma with delta? Use of option gamma for option traders. Now, what exactly is option gamma? Option gamma is the rate of change of delta with change in the spot price of the underlying asset. Mathematically, delta is the partial derivative of the option price with spot price of an underlying asset. So gamma is the second order partial derivative of the option price with the spot price of the underlying asset. Now the delta of a call option is given by the formula ND1 and of a put option is given by ND1 minus 1, where N is the normal cumulative probability distribution of D1. As differentiating ND1 and ND1 minus 1 with the spot price gives the same result, that is N dash D1. So both call option and put option have the same gamma value for the same set of other variables like strike price and time to expiry. In a normal distribution, the differentiation of the cumulative density function gives the probability density function as depicted by the graphs below. Now, these are the graphs of PDF and CDF of standard normal probability distribution with equation of a PDF function mentioned below. Now, integrating the PDF over a range gives the CDF, and differentiating the CDF gives the PDFs. Now, how to calculate the gamma value? Below are the PDF and CDF graphs of B1 of an option whose details are mentioned in the box. Both the graphs have probability on y-axis and D1 values on y-axis, on x-axis. As CDF shows the total probability associated with up to a specific value of D, so it is the delta. So differentiating CDF gives probability associated with specific value of D1, that is the rate of change of delta, which is the gamma. Now let's draw two vertical lines on the central part of the CDF graph. As CDF graph has higher slope between the two vertical lines, so PDF is high around the region. So gamma is high when the spot price and strike price are near to each other. How to depict the relationship of gamma with delta? The first graph shows the C value of an option whose details are given below. The second graph shows the delta value of the call option across various spot prices. As the tangents drawn to different points of the call option value curve have different slopes, so delta of the call option varies with changes in the spot price. As tangents drawn to different points of the delta value curve have different slopes, so gamma of a call option varies with changes in the spot price. So to predict the call option value over a change in spot prices, the second term Taylor series needs to be used. the gamma value to be used as the second term in the Taylor series. Now, how to use gamma for predicting option price for a change in spot price of the underlying asset. The below graphs show the call option values and gamma values over various spot prices for an option whose details are given below. The call option value increases from 34 to 43.61 when the price increases from 130 to 40. The difference in call option values could be predicted with high accuracy using delta and gamma. Now we predict the call option values at spot price of 140 by using delta and gamma. The delta at spot price of 130 is 0.87, as could be seen from the previous slide. The formula used for Taylor series second term is gamma into 0.5 into x2 minus x1, which is the difference in the spot price, which is 10 to the power 2. The calculation is shown at the bottom right box, where the option price is predicted with an error of just 0.03. For more accurate prediction of the option price, the third term of Taylor series also needs to be used, but that is beyond the purview of this presentation. Now, what are the broad uses of option gamma in a real-life trading situation? Gamma could be used for predicting the option value over a change in spot price of the underlying asset, but this assumes the implied volatility of the underlying asset remains constant. The implied volatility of an option generally has low volatility over a short period, say a month. So gamma is generally useful in predicting the option price. The option trading strategy based on delta neutrality sometimes needs gamma hedging addition to delta hedging. As gamma coefficient measures delta sensitivity, so gamma tracking is crucial in a volatile market. Generally, gamma of options is high when spot price is around the strike price and when time to expire is low. As gamma is an integral part of risk management, it has widespread use in high-frequency trade and option spread-based trading. So that concludes the presentation. Thanks for watching.